Let's solve some questions on geometric progression. In the previous videos, we have solved questions on arithmetic progression. So, for example, if I write the number series 1, 3, 5, 7, and 9, and so on, the first number is 1, and the difference between two consecutive numbers is 2. 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So I will say that 2 is the common difference for the consecutive numbers, and this forms a arithmetic progression or AP. But if I have a number series like 1, 2, 4, 8, 16, and so on, the first number is 1 and the next number is 2. So the second number divided by the first number, 2 by 1 is equal to 2. The third number divided by the second number, 4 by 2 is equal to 2. The fourth number divided by the third number, 8 by 4 equals to 2. Even 16 by 8 is 2. So I will say that the common ratio between consecutive terms is the same number, and here it is 2. In case of AP, the common difference was denoted as D. D was equal to 2 in the first example. In the second example, the common ratio R is equal to 2. So this becomes a geometric progression, any series where the consecutive terms have a common ratio. Now suppose in this question they are giving me the fourth term of the GP, which is 16, and seventh term of the GP, that is 128, and we are supposed to find what is the first term and the common ratio of the series. First term is A and common ratio is R. They are asking for these two numbers. Now we can find out the nth term of a GP. There is a direct formula. For example, the first term of a GP is A. The second term will be A multiplied by the common ratio R. The third term will be A R multiplied by R, which is R square. The fourth term will be AR cube. So therefore, the nth term AN will be equal to A into R to the power n minus 1. Like in an AP, the nth term was A plus n minus 1 into D. That was a general formula. The same we have for a GP. So in this question, the fourth term, which is A4, is given as 16. So that means A4 can be written as A into R to the power of 4 minus 1, that is 3. And this is 16. This can be the first equation. Then the seventh term, A7, is given as 128. So the seventh term can also be written as A R to the power 7 minus 1, that is 6. And that is 128. This is equation 2. Now I want to find the values of A and R. They are the two unknowns. So I can look at these two equations and see that both the equations have a A, which is multiplied. So I can divide both the equations. For example, I can take equation 2 divided by equation 1. So then the left side I have AR to the power 6, and the first equation's left side is AR cube, and that should be equal to 128 divided by 16. Now the first term is not 0 because the other numbers are positive, 16 and 128. So I can easily cancel out the first term, that is A, and I will have R to the power 6 by R to the power 3. That division will give me R cube, and that is equal to 128 by 16. If we simplify, we should get this is 8. So R cube is equal to 8. So that means taking cube root, R will be equal to cube root of 8, that is 2. So the common ratio R is equal to 2. Now we should also know that common ratio can be any number. It can be positive, it can be negative. We are not considering 0 here. But suppose if I had an equation like R square equals to 4, then the possible values of R will be plus minus root 4, that is plus or minus 2, because plus 2 square is 4, minus 2 square is also 4. But for odd exponents like R cube or R to the power 5, we will only have one possible option, because 2 cube is 8, but minus 2 cube will be minus 8. So if we have even exponents, you have to be careful to consider both the positive and the negative. Okay, but anyway, this is not the case in this question. Now we need to find what is the first term a. So I can look at equation 1. Equation 1, ar cube was equal to 16. So I can say that a into 2 cube is equal to 16. 2 cube is 8. So a value is 16 by 8, that is 2. So the first term is 2 and the common ratio r is also 2 for this question.